The Phalanx CIWS is a close-in weapon system for defense against anti-ship missiles. It was designed and manufactured by the General Dynamics Corporation, Pomona Division. Consisting of a radar-guided 20-on Gatling gun mounted on a swiveling base, the Phalanx is used by multiple navies around the world, notably the Royal Navy and the United States Navy on every class of surface combat ship, by the United States Coast Guard aboard its Hamilton-class and Legend-class cutters and the navies of 16 allied nations. A land-based variant, known as CRAM, has recently been deployed in a short-range missile defense role, to counter incoming rockets and artillery fire. Because of their distinctive barrel-shaped radome and their automated nature of operation, Phalanx CIWS units are sometimes nicknamed a 2D2 after the famous droid from Star Wars. History: the Phalanx close-in weapons system was developed as the last line of automated weapons defense against anti-ship missiles, including high-G and maneuvering sea skimmers. The first prototype system was offered to the U.S. Navy for evaluation on Usher King in 1973, and it was determined that additional improvements were required to improve performance and reliability. Subsequently, the Phalanx operational suitability model successfully completed operational test and evaluation aboard Usher Bigelow in 1977. OSM exceeded operational maintenance, reliability, and availability specifications. DSARCIAI followed OPEVAL, which was followed by approval for production in 1978. Phalanx production started with orders for 23 United States dollars and 14 foreign military sales systems. The first ship fully fitted out was the Usher Coral Sea in 1980. The Navy began placing CIWS systems on non-combatant vessels in 1984. Design: the basis of the system is the 20mm M61 Vulcan Gatling gun autocannon, used since the 1960s by the United States military in nearly all fighter aircraft, linked to a Ku-band radar system for acquiring and tracking targets. This proven system was combined with a purpose-made mounting, capable of fast elevation and traverse speeds, to track incoming targets. An entirely self-contained unit, the mounting houses the gun, an automated fire control system and all other major components, enabling it to automatically search for, detect, track, engage, and confirm kills using its computer-controlled radar system. Due to this self-contained nature, Phalanx is ideal for support ships, which lack integrated targeting systems and generally have limited sensors. The entire unit has a mass between 5,500 and 6,100 kg. Upgrades: due to the continuing evolution of both threats and computer technology, the Phalanx system has, like most military systems, been developed through a number of different configurations. The basic style is the Block 0, equipped with first-generation solid-state electronics and with marginal capability against surface targets. The Block 1 upgrade offered various improvements in radar, ammunition, computing power, rate of fire, and an increase in maximum engagement elevation to +70 degrees. These improvements were intended to increase the system's capability against emerging Russian supersonic anti-ship missiles. Block 1A introduced a new computer system to counter more maneuverable targets. The Block 1B PSUM adds a forward-looking infrared sensor to allow the weapon to be used against surface targets. This addition was developed to provide ship defense against small vessel threats and other floaters in littoral waters and to improve the weapon's performance against slower low-flying aircraft. The FLIR's capability is also of use against low observability missiles and can be linked with the RIM-116 rolling airframe missile system to increase ram engagement range and accuracy. The Block 1B also allows for an operator to visually identify and target threats. The U.S. is in the process of upgrading all their Phalanx systems to the Block 1B configuration. All Phalanx systems in use by the U.S. Navy are scheduled to be upgraded to Block 1B by FY 2015. The Block 1B incorporates a stabilized forward-looking infrared sensor, an automatic acquisition video tracker, optimized gun barrels, and enhanced lethality cartridges for additional capabilities against asymmetric threats such as small maneuvering surface craft, slow-flying fixed and rotary-winged aircraft, and unmanned aerial vehicles. The FLIR sensor improves performance against anti-ship cruise missiles, while the OGB and ELC provide tighter dispersion and increased first-hit range. The Mk244 ELC is specifically designed to penetrate anti-ship missiles with a 44% heavier tungsten penetrator and an aluminum nosepiece. Another system upgrade is the Phalanx 1B Baseline 2 radar to improve detection performance, increase reliability, and reduce maintenance. It also has a surface mode to track, detect, and destroy threats closer to the water's surface, increasing the ability to defend against fast attack boats and low-flying missiles. The Baseline 2 radar upgrade is to be installed on all U.S. Navy Phalanx systems by FY 2019. The Block 1B is also used by other navies, such as Canada, Portugal, Japan, Egypt, Bahrain, and the UK. In May 2009, the U.S. Navy awarded a $260 million contract to Raytheon Missile Systems to perform upgrades and other work on the Phalanx. Comparison with other CIWS, Operation: the CIWS is designed to be the last line of defense against anti-ship missiles. Due to its design criteria, its effective range is very short relative to the range of modern ASMs, from 1 to 5 nautical miles. The gun mount moves at a very high speed and with great precision. The system takes minimal inputs from the ship, making it capable of functioning despite potential damage to the ship. The only inputs required for operation are 440 VAC 3-phase at 60 Hz and water for electronics cooling. For full operation, including some non-essential functions, it also has inputs for true compass ship's heading and 115 VAC for the PASS subsystem. Radar subsystems: the CIWS has two antennas that work together to engage targets. The first antenna, for searching, is located inside the radome on the weapon control group. The search subsystem provides bearing, range, velocity, heading, and altitude information of potential targets to the CIWS computer. This information is analyzed to determine whether the detected object should be engaged by the CIWS system. Once the computer identifies a valid target, the mount moves to face the target and then hands the target over to the track antenna. The track antenna is extremely precise, but views a much smaller area. The tracking subsystem observes the target until the computer determines that the probability of a successful hit is maximized and then, depending on the operator conditions, the system will either fire automatically or will recommend fire to the operator. While firing, the system tracks outgoing rounds and walks them onto the target. Gun and ammunition handling system: the Block 0 CIWS mounts fired at a rate of 3,000 rounds per minute and held 989 rounds in the magazine drum. The Block 1 CIWS mounts also fired at 3,000 rounds per minute with an extended magazine drum holding 1,550 rounds. The Block 1A and newer CIWS mounts fire at a rate of 4,500 rounds per minute with a 1,550 round magazine. The velocity of the rounds fired is approximately 3,600 feet per second. The rounds are armor-piercing tungsten penetrator rounds or depleted uranium with discarding sabots. The Phalanx CIWS 20mm rounds are designed to destroy a missile's airframe and make it unaerodynamic, thus keeping shrapnel from the exploding projectile to a minimum, effectively keeping collateral damage to a minimum. The ammunition handling system has two conveyor belt systems. The first takes the rounds out of the magazine drum to the gun. The second takes empty shells or non-fired rounds to the opposite end of the drum. CIWS contact target identification: the CIWS does not recognize identification friend or foe, also known as IFF. The CIWS only has the data it collects in real time from the radars to decide if the target is a threat and to engage it. A contact has to meet multiple criteria for it to be considered a target. Some of the criteria are listed below. Is the range of the target increasing or decreasing in relation to the ship? The CIWS search radar will see contacts that are outbound and discard them. The CIWS will only engage a target if it is approaching the ship. Is the contact capable of maneuvering to hit the ship? If a contact is not heading directly at the ship, the CIWS looks at its heading in relation to the ship and its velocity. It then decides if the contact can still perform a maneuver to hit the ship. Is the contact traveling between the minimum and maximum velocities? The CIWS has the ability to engage targets that travel in a wide range of speeds. However, it is not an infinitely wide range. The system has a target maximum velocity limit. If a target exceeds this velocity, the CIWS will not engage it. It also has a minimum target velocity limit. Any contact below that velocity will not be engaged by the CIWS. The operator also has the option to adjust the minimum and maximum limits within the limits of the system. There are many other subsystems that together ensure proper operation, such as environmental control, transmitter, mount movement control, power control and distribution, and so on. It takes 6 to 8 months to train a technician to maintain, operate, and repair the CIWS. Incidents: drone exercise. Catastrophic accidents. On February 10, 1983, the USA Antrim was conducting a live-fire exercise off the east coast of the United States using the Phalanx against a target drone. Although the drone was successfully engaged at close range, the target debris bounced off the sea surface and struck the ship. This caused significant damage and fire from the drone's residual fuel, which also killed a civilian instructor aboard this ship. On October 11, 1989, the USA El Paso was conducting a live-fire exercise off the east coast of the United States using the Phalanx against a target drone. The drone was successfully engaged, but as the drone fell to the sea, the CIWS re-engaged it as a continued threat to the El Paso. Rounds from the Phalanx struck the bridge of the USA Iwo Jima, killing one officer and injuring a petty officer. Iraqi missile attack in 1991. Gulf War. On February 25, 1991, during the First Gulf War, the Phalanx-equipped frigate USA Jarrett was a few miles from the U.S. battleship USA Missouri and the British destroyer HMS Gloucester. The ships were attacked by an Iraqi Silkworm missile, at which time the Missouri fired its SRBOC chaff. The Phalanx system on Jarrett, operating in the automatic target acquisition mode, fixed on Missouri's chaff, releasing a burst of rounds. From this burst, 4 rounds hit Missouri, which was 2 to 3 miles from Jarrett at the time. There were no injuries. A Sea Dart missile was then launched from Gloucester in a tail-end engagement, destroying the Iraqi missile as it passed between Gloucester and Missouri, achieving the first successful engagement of a missile by a missile during combat at sea. Accidental downing of U.S. aircraft by the Japanese destroyer Yajiri. On June 4, 1996, a Japanese Phalanx accidentally shot down a USA-6 intruder from the USA Independence that was towing a radar target during gunnery exercises about 1,500 miles west of the main Hawaiian island of Oahu. A Phalanx aboard the Asagiri-class destroyer Yajiri locked onto the intruder instead of the target. Both pilots ejected safely. A post-accident investigation concluded that the Yajiri's gunnery officer gave the order to fire before the A-6 was out of the CIWS engagement envelope. 21st century, Centurion C-RAM. Seeking a solution to constant rocket and mortar attacks on bases in Iraq, the United States Army requested a quick-to-field anti-projectile system in May 2004, as part of its counter-rocket, artillery, mortar initiative. The end result of this program was Centurion. For all intents and purposes a terrestrial version of the Navy's CIWS, the Centurion was rapidly developed, with a proof-of-concept test in November that same year. It began deployment to Iraq in 2005, where it was set up to protect forward operating bases and other high-value sites in and around the capital, Baghdad. Israel has purchased a single system for testing purposes, and was reported to have considered buying the system to counter rocket attacks and defend point military installations. However, the swift and effective development and performance of Israel's indigenous Iron Dome system has ruled out any purchase and deployment of Centurion. Each system consists of a modified Phalanx 1B CIWS, powered by an attached generator and mounted on a trailer for mobility. Armed with a 20mm M61A1 Gatling gun, The unit is capable of firing 4,520 mm rounds per minute. In 2008, there were more than 20 CIWS systems protecting bases in the U.S. Central Command Area of Operations. A Raytheon spokesman told Navy Times that 105 attacks were defeated by the systems, most of those involved mortars. Based on the success of Centurion, 23 additional systems were ordered in September 2008. Like the naval version, Centurion uses Ku-band radar and FLIR to detect and track incoming projectiles, and is also capable of engaging surface targets, with the system able to reach a 25-degree elevation. The Centurion is reportedly capable of defending a 1.2 km² area. One major difference between the land and sea-based variants is the choice of ammunition. Whereas naval Phalanx systems fire tungsten armor-piercing rounds, the CRAM uses the 20mm HEITSD ammunition, originally developed for the M163 Vulcan air defense system. These rounds explode on impact with the target, or on tracer burnout, thereby greatly reducing the risk of collateral damage should any rounds fail to hit their target. CRAM, utilizing the armament of the RIM-116 rolling airframe missile, and based on the mounting and targeting systems of the Phalanx, CRAM was developed in response to concerns about the performance of gun-based systems against modern, supersonic sea-skimming anti-ship missiles. Designed as a companion self-defense system to Phalanx, the CRAM is equipped with an 11-cell RAM launcher, and provides defense at a longer range. Due to the common mounting, CRAM inherits the relatively easy installation characteristics of its gun-based sibling, with Raytheon stating that, CRAM fits the exact shipboard installation footprint of the Phalanx, uses the same power and requires minimal shipboard modification. Currently in the trial stages, CRAM is fitted to the Independence-class littoral combat ship. Operators, specifications. Gun, 1 20 mm 61 Vulcan 6-barreled Gatling cannon, height, 4.7 am, weight, 12,500 lb, later models 13,600 lb, elevation at 25 degree to plus 85 degree, muzzle velocity, 1,100 ams, rate of fire, 4,500 rounds minute, maximum burst size, 1,000 rounds, ammunition capacity, 1,550 rounds, radar, Ku-band, 100% kill distance, classified, cost, $35 million, similar systems, AK-630, Russian CIWS. Kashtan CIWS, Russian gun missile CIWS, Goalkeeper CIWS, Dutch CIWS, Meroka CIWS, Spanish Navy, Barak 1, Israel. Missile-based, RIM-116 rolling airframe missile, U.S. missile-based, Type 730 CIWS, Chinese CIWS, references, notes. External links, official United States Navy Warfighters Encyclopedia CIWS page, globalsecurity.org fact file, Raytheon Company Phalanx CIWS product page.